All right, so let's start the chapter 12.1 review. So use circle A to find the measure of FHG. Now remember, measure means that we want the degree, right? So we're gonna follow this exact degree, FHG, in that same order. F H G. So that means we want all of this. So that means I'm gonna have to take this little piece that I didn't use and subtract it from the entire thing. Minus 53, 10, 5, 307. And that's my answer. All right, so next one. Use A to find the length of CH. Okay, so length now is not degrees. Length is like an actual unit of measurement. Feet, yards, centimeters in this case. So I'm gonna have to use sector, circumference. Theta over 360 times pi r2. So CH, so I still need to find my CH here. And so if this is 90 and this is 33, my entire thing is going to be what, 123? 123. So now let's put that 123 degrees into my theta. So circumference equals 123 divided by 360 times pi. What's my r? My radius is 60, so 60 times 2 is 120, right? 120 over 1. So I'm gonna, this 120 can be substituted to 1 or factored out to 1, and this can be 3. So now I have 123 pi over 3, and I know that 123 divided by 3 is equal to 41 pi, and that's my answer. All right, so next one. So now lines that appear to be tangent or tangent, that means that they're saying that this line is tangent, okay? So I'm just gonna backspace that. I'm just gonna put 90 degrees because I don't wanna mess with these. You guys see how there's like these little crevices right there? Those are important. So I don't wanna muck it up by doing that. Okay, so lines that appear to be tangent, tangent. O is the center. What is the value of X? Okay, so they're asking what is the value of this? So I'm gonna realize, okay, yeah. So I'm gonna realize that this right here is a radius, right? What else is a radius? This is a radius as well. So if this is a radius and that's a radius, well, doesn't that mean that these both are gonna be the same? And if these both are the same, then that means I can take this 65 because they're what? They're base angles, right? Base angles in an isosceles triangle are always congruent. So if this one's 65, then this one's also 65. So now to find this angle right here, I just have to take the sum of 65 and 65 and subtract it from 180, the triangle angle sum theorem. So 65 plus 65 equals 130. So that means 180 minus 130 is 50. So this has to be 50 degrees. So if that, so now let's kind of erase some of these stuff because it kind of is looking confusing. So all I know is that this is 50, so that's important. Now, if this is 50 and we know that this is 90, right? Because of this, correct? Now, what is 90 plus 50 plus X equals 180? So my answer should be 40. So let's see if it is 40. And it is right here, 40, okay? So now what about this one? In the given figure, what is the value of X? Okay, so here I don't have any angles, right? I only have the 90, but 90 can't be my perspective angle. So a lot of people would think, okay, well, we gotta use SOHCAHTOA, or I gotta use 30, 60, 90. What if this is 30, this is 9, this is 60? I have no idea of knowing that. So I can't use that. The only thing I can use, the only thing I know is that this is a right triangle. And what I want to find is not the angles, I want to find the side lengths. So what formula can I use that involves triangles and side lengths? Well, I can use Pythagorean's theorem. So c squared equals a squared plus b squared. Now, my c is the most important one. That's the hypotenuse, so it has to be this side right here. This is my c. Now, what is my c? Is it just 10? No, it's 10 plus this x. So I'm going to have x plus 10 equals, let's put, this is my a and this is my b. Doesn't really matter, right? And then this would be, what's 20 times 20? That's 400. So now, whoops, I forgot to add that. Do you guys remember that this, the way we do this is we do, what is x squared? Well, x squared. What is 10 squared? It's 100. Now, what is x times 10 times 2? That's plus 20x equals x squared plus 400. Now, I'm going to move all my constants to one side and all my variables to another. So I'm going to subtract x squared here, subtract x squared here. And what happens? These guys cancel out. Now I'm going to subtract 100, subtract 100. So I'm going to have 20x equals 300. Now I divide by 20, divide by 20. This cancels out with that. What's 30 divided by 2? It's 15. So my x should be 15. Is it? Yep, 15. Perfect. So now, in the figure to the right, if AC is 16, okay, so let's write that. Let's write AC is 16. So all this is 16. We can color code it. BC is 13. What is the radius? Well, isn't the radius just AB? Yeah, because it's from the center to a point on the circle. So we just got to use Pythagorean's theorem, right? We just got to use Pythagorean's theorem to find this radius. So the most important one is my C, which is supposed to be opposite to the 90, which is this one. So now, what is 16 times 16? I actually don't have a calculator and I'm using my phone. So I'm just going to do 16 squared equals 13 squared plus r squared. This is the c squared equals a squared plus b squared. So I think you guys know how to use the calculator. So just, dang, what's 16 times 16? I'm gonna just do that one real quick. 6, 3, 9, 0, 6, 1, 6, 5. 256, I hope it is 256. 13 times 13 I know is 169. Plus r squared minus 169 minus 169. So now just find your square root of 107. And that's because the way to get rid of a square is to do what? Square root it. So now my r equals square root of 107 or whatever the equivalent is, which I assume it's this. Okay? And if it's not, then that means I did something wrong with my math, but I think you guys can figure it out from here. I think everybody should know how to do this, correct? How to do this, how to do that, okay? So now let's move on. Determine whether a tangent is shown in the diagram. Okay, so just determine whether a tangent is shown. So well, what is a tangent? A tangent is a line that crosses a circle at only one point. So this obviously can't be the tangent they're talking about, because if we keep this going and going and going, it's going to touch this, which makes it a what? A secant line. So that means the line that they have to be talking about has to be this one, because it's going to touch at one point and make a 90 degree. So if we're going to say that this is 90 degrees, then I'm going to have to we have to assume that it is 90 degrees. And now this has to be my C value. This has to be my A value, and this one's my B value. So I'm going to do 3.5 squared equals 2.1 squared plus 2.8 squared. Now, once again, I don't have a calculator on me right now. So when you guys do this math, right, when you guys do all this, if this truly does equal this plus this, so like let's say this is 1,000, right? And then this is also 1,000, then we can put an equal sign, right? And what do we know about when I have my c squared equal to my a squared plus b squared? That means that it is a right triangle. Therefore, a right triangle has to have a 90 degree. So let's see what it was. So yes, so that means that these guys together do add up to equal not 1,000. They are equal to each other. Therefore, this is a right angle, which means that therefore this is a tangent line. And if this is a tangent line, the line that is tangent is the 2.8 is perpendicular to the 2.1. So yes, because the segment that measures 2.8 is perpendicular to the radius, which is what we just said, that this line is indeed perpendicular to this radius. Cool. All right, so this one should be super easy because the polygon is circumscribed in a circle. What is the perimeter? Well, we know that if you have two tangent lines forming at one common endpoint that meet up at a common endpoint, that means that whatever this line segment is, which here it said it's 6, that means that this one's also going to be 6. So therefore, if this is 9, so is this one. This one would be 13, and this one would be 8. So 13 plus 13 is 26, plus 16, plus 12, plus 18. So 12, 14, 22, right? 2, 4, 5, 6, 7. So it should be 72 if my math is right. Yeah, perfect. There you go. So now this one's very easy. Draw the circles in the same relationship. So what are the two relationships that these two circles have? Well, they each have, this has one tangent line, and this part of the circle has the other tangent line. That's it. There cannot exist an interior tangent line, because then, look, notice here, I'm touching this blue circle at this point, and then I'm touching this blue circle at another point. Also, these circles are not tangent to each other, because for circles to be tangent, they have to look like this, correct? They have to touch each other only at one point. So the only relationship that these two circles have is that they have two exterior tangent lines. This one, no. This one has nothing, which is not true, and this one does not just have one. They have both, okay? So what's this? Okay, the circle at the right represents, the circle at the right represents the planet. The radius of the planet is about 5,300 miles, okay? So let's write that down. The radius is 4,300. That means that this guy's also 4,300. Find the distance d to the horizon that a person can see on a clear day from a height, which is h, this guy, of 1921 feet. A person, and now let's answer the question. A person can see a distance of approximately blank miles. Okay, so that means I'm gonna have to convert this feet into miles, because my final answer is gonna be in miles. So the way we do that is we write 1921 feet times, we gotta have the unit feet under here, because what's gonna happen is that, whoops, when we have the unit of feet under there, this is gonna divide with this to cancel out. Okay, just like how like 5 pi times 1 over 10 pi exist. When we do 5 pi times this, wouldn't we just get 5 pi over 10 pi? And when I do that, these guys are going to cancel out. So in that same way, when these guys cancel out, so do they when they're cross multiplying like that. Okay? So, and 5,280 feet in 1 mile. So this and this are going to cancel out, and I'm going to be left with just miles. So 1921. So where's the calculator? $19.21 divided by 5280. That's going to give me 0.3638. 3638 miles. So now if I plug this into my h, I'm going to get 0.3638. Now, in order to find my d, that's the one I wanted to find, right? I want to find this d value. So I'm going to have to use Pythagoras theorem, right? So what is my c? This is my c because it's opposite the 90 degrees. Let's let that be my a and this be my b. So now this entire length right here, is 4,300 plus this 0.3638. So let's write that here. Let's do c squared equals a squared plus b squared. What's my c squared? It's 0.36. Whoops. It's gonna be 4,300.3638 squared equals a squared, which is my d squared, plus 4,300 squared. So now just, 3638. So that giant number, so we're gonna take, I'm not gonna write all this down. So we're gonna take this giant number. So let's put giant number equals d squared plus other giant number, right? Other number. And now we're gonna subtract this other number from this giant number. So subtract. So this giant number minus this other number right here. And I don't know, let's put blah. So now my giant number minus my other number will give me blah is equal to d squared. And how do I get rid of this d squared? I got to square root it. So whatever this blah number is, we're going to square root it. And that should give me, rounded to the nearest tenth, this distance. Okay? So now let's go on to the other one. The segments BD and CK at the right are diameters, okay? BP and QP are tangent, okay? So I'm gonna do this. Tangent, okay? Find measure of angle 5. So I want this. Well, okay, I got it. So now, if this little angle right here is 25, if this little angle here is 25, then that means this 6 also has to be 25. So now, if this is 25 and this is 90, what does this have to be? Well, let's find out. So 180 minus, what's 90 plus 25? 115, right? 10, 7, so 65. So that means this 4 has to be 65. And if this is 65, and if this is 65, then so does this have to be 65 as well. Now, I'm gonna use linear pair theorem to find out what's the measure of angle 5. So 65 plus 65 is 130. So that means this 5 has to be 50. Is it? Yep, 50. And last one, I'm purposely putting this because it's gonna get you guys confused and you guys are gonna read it and give up, but it's really not hard. So knowledge of tangent lines to a circle is needed to calculate. Okay, cool. 2 circular pulleys are to be connected. Okay, use triangle ACO to find the length of CO. So I want to find the length of CO and DO. Okay, note CF and DE are tangent to both circles. Okay, so CF and DE are both tangent, so CF is tangent, so that means I can put a 90 here and a 90 there. Now, if I know that this radius is 40, that means this radius is also 40. And what do I know about this length right here? This length right here is how long? It's 85. So really, don't I just have a Pythagorean theorem? This has to be my C. This has to be my C. This would have to be my A, and this has to be my B. So now I'm just gonna have 85 squared equals A squared, which is what, 40, plus B squared. So now 85 times 85, 7225 is equal to 4 times 4 is 16, so it's going to be 1600 plus B squared minus 1600 5, 2, 12, 6, 5. Am I doing that right? I feel like that's so wrong. 5625 square root, nope, 75. So now the square root of B squared, to get rid of this squared, let's square root it. And now what's the square root of 5625? My B is 75.